So guys, you can see that this is the CH340 USB to TTL device over here, and this is a DHT11 sensor. Now you can see the device is blinking, it means the data is being sent. Now take a look here. Now this is the data we are getting. See, 20, I clear the screen, so see, it is sending the data like 20 degrees centigrade and 64% humidity. So simple as that. Now let me give you a recap of the coding as well. So you can see that what we did is that I took the code from my previous video. We made three functions here, one to initialize the sensor, one to get the response, and one to acquire the data. And then we simply use these to get the data in 4 bytes form, integral part of humidity and the decimal part of humidity, likewise for the temperature. Then we did the checksum check, and then we simply displayed the data by converting it into a string on our UART terminal. So simple as that. Hello guys, welcome to learning microcontrollers. In this video, I will show you how you can interface a DHT11 temperature and humidity sensor with a PIC16F877A microcontroller, and then we will send the output on the PC using a USB to TTL device. So in short, how you can connect a sensor with a PIC and then you can use your computer as a monitor for that. So that's what we're gonna do here. We will be using a USB to TTL device. You can use any USB to TTL device, FT232, CH340, CP102, whichever you use. Remember to install the driver as well. So let's get started. So guys, this is our PIC16F877A having 40 pins. It's a DIT version. This over here is the DHT11 humidity and temperature sensor. So let me show you how to connect it with a PIC. So you can see that this module has 3 pins. The bottom one is a signal, then 5 volt, and then the ground. Now guys, let's connect them. For the signal, you can use any available digital input output pin. I'm going to use a pin number D0. For the 5 volt, I'm going to use the VCC pin of the PIC and ground to the ground of the PIC like this. In this way, your DHT11 module is connected. Now guys, this over here is the CH340 USB to TTL device. FT232 also have exactly the same pin configuration. Whichever the USB to TTL device you use, remember that these 3 pins, TX, RX and ground, these 3 pins are always there. You may use CH340, you may use FT232, you may use CP1102, whatever they call it. These 3 pins are always there. So these 3 pins mean that this is a UART based device, and we only need these 3 pins in our project. And sometimes in few modules there is no 3.3 volt option, but there is a 5 and VCC volt option like in every module. So it's up to you, you want to use the power from here or not. So let's do the connection. So let me relabel the device for you. Top one is a 5 volt pin, then VCC 3.3 volt, TX, RX and ground. Now guys, connect the ground of the CH340 USB to TTL device with the ground of your PIC microcontroller, the common ground like this. Then guys, for the RX pin of your USB to TTL device, you will connect it to the TX pin of the PIC, that is pin number 25 or C6 pin. Now guys, for the TX pin of your CH340 device, you will connect it to the RX pin of the PIC, that is pin number 26 of the PIC or C7. So in this way, TX of the CH340 or USB to TTL device will go to the RX of the PIC, and RX of the USB to TTL device will go to the TX of the PIC. Now guys, we will not need to connect the power because computer will power up the CH340 or your USB to TTL device, because when we will plug it into the computer will power up this device. So in case for the PIC, I'm going to use a PIC at 3.5. So PIC at 3.5 will power up the PIC and the DHT11, while computer will power up the CH340. If you don't want to use a PIC at 3, you want to use the computer's power to run the whole circuit, then you will connect the 5 volt pin to the VCC of the PIC. In this way, computer will also power up your DHT11 and PIC circuit. But in my case, I am going to use a PIC at 3 to power up the PIC and the DHT11, and computer will auto power up the CH340 USB to TTL device. So in this way, our connections are completed. So let me introduce you to the hardware, then we move on to the programming. So guys, this over here is my hardware. This is the computer's USB extension port, and this over here is a FT232 USB to TTL device. You can see that it's mentioned as well. And this over here is a DHT11 sensor, and this over here is a PIC16F877A microcontroller, that is the PIC at 3. Now see that this will power up the CH340, it's already powered up, while the PIC is not powering up the circuit, it's off. Still this LED is on because computer is powering up the circuit. So if you want to power up your PIC with this as well, just disconnect the PIC at 3 and connect a wire, 5-volt wire from here to the PIC. Simple as that. Rest of the board is just a trainer board, so forget about the other wirings. So there is a DHT11, there is a USB TTL device, there is a PIC, and there is a PIC at 3. That's all. Now guys, let's get to the programming. Let me get you to the MikroC for PIC. So guys, this is our MikroC for PIC. Let me zoom in so you guys can see better. As you can see that this is version 7.2.0. Higher versions are also available. Always use the higher version if available, because higher is always better. Click on File, New Project. This window pops up, New Project Wizard. Click on Next. Write the name of the project. I write DHT11 output on PC using USB to TTL device tutorial by learning microcontrollers. So this is the name I wrote. You can write any name that you want, and this is the path where the files will be created. Select the microcontroller you are going to use. I'm going to use the PIC16F877A, and the crystal I have at the pin number 13 and 14 is a 20 megahertz. Click on Next and Finish. Now guys, this over here is the page that will come in front of you. Before you do anything else, press Ctrl S to save your work. Now the work is saved. Now guys, we are going to use a code from one of my previous video that will work here as well. I had explained the code in detail in that video. I will also share the link to that video in the description of this video. So go to your browser, go to the YouTube, just write the YouTube, and go to the YouTube, and then you have to go to my channel. I will share the link directly to you. So simply write down here learning microcontrollers. It had popped up. Okay, in my channel there is a video called, okay, in the videos, just write down here DHT11, search. So various videos pop up. This video over here, just click on it. Okay, and in the description of this video, you go to the description of the, I will share this link. I will share this link over here in the description of this video, so you will directly get to this video. In the description here, you have this Google Drive file. Just open this file. Once you open this, it will lead you to this window. Here you have this folder. It has the files I made in that video. You will have the link to that video. So if you want to learn the code how it's made, just go to that video. And just we have to download this file. Go here and click on this download button. Okay, let it download. Okay, the file is downloading. See, let it download. Okay, it's downloaded. Just a small file. Just go to the folder where you had downloaded this file, and here you have this zip file. Copy it wherever a suitable place where you want to extract the files. I just copy it here in this folder, and in this folder I paste it here somewhere and extract the file. This will extract the MikroC for PIC files. Okay, now inside this you have these various files. Just go to your MikroC, just open this file, C file, or you can also open it using the MikroC. It will also do, this is the code. You copy this code, press Ctrl C and go back to the window where you just created a MikroC for PIC file. Now you paste it here, press Ctrl A, Ctrl V, the file is here. Now go to the right, select the libraries. In this file we use the following libraries. You have to select them: conversion library and the UART library. Simple. Now guys, the same coding, let me give you a recap. See, here we just initialize some variables. Then we have a function called initialize the sensor. Then as per the data sheet of the DHT11, we gave the signals, and then guys we took a response from the sensor. For that we use another variable sensor response. Then as per the data sheet we took the response from the sensor. Then we made another function data acquisition, and again we use a data sheet to get how we will acquire the data in 40 bytes from the sensor, 40 bits from the sensors. Now guys here, then we go to our main loop. We just initialize the pin we are going to use for the DHT11, that is D.F0. Then we initialize the UART port. That is also in case of a Bluetooth module, we use the same port. And in case of a CH340 or a USB to TTL device FT232, we will also need the same. And baud rate 9600, this is fine. And this is some initialization delay. And then guys, for the power up time, as per the data sheet, 1 second time is needed by the DHT11 sensor to power up the circuit. So we just gave a random delay. Then we call the first function, then we call the second function of sensor response, and then we see if the response is 1, like the response is coming from the sensor. We acquire the data from the sensor as per the data sheet in the form of bytes. And this is the integral part of the RH, and this is the decimal part of the humidity, and this is the integral part of the temperature, and this is the decimal part of the temperature. And then we acquire the checksum as shown in the data sheet, and then we check if the checksum, if the sum of all four values we acquired earlier, then it means our answer is correct, that the data received is correct, and then we simply display the temperature. Now we have this temperature TB1. We are only going to display the integral part because this answer is not accurate enough to be of decimal part to be of any use. So we will only display the integral part. So TB1 is the integral part of the temperature. And then we use the int to string command. We convert this into a string because we cannot display integers directly on the LCD, or we cannot transmit integers over the UART channel in PIC. So we will transmit them in the form of strings to be displayed on the screen, because serial terminal can only display something called strings, ASCII, because that is what we understand. So we simply convert it into temperature 1, and then we send it over the UART channel. This is a UART channel. Temperature equals to that is what will be displayed on the screen to make it look beautiful, and this is the value, whatever the value is converted, and then we will display a C because it is in the form of centigrade. Now for the humidity, again only the integral part, that is the RB1, this part, integral part, will be displayed. We store it in the humidity 1 integer variable, and then we convert it into a string. Then we send it over the UART channel. To look it beautiful, we will display humidity equals to first, and then whatever is in this, and then on the screen. Else, if there is a checksum error, then it will display that there is a checksum error. If the sensor is not responding, then this will display the sensor not responding. Simple as that. So let's get to the hardware and let's run this code and see what happens. So let me build it. So it's built successfully, no errors. I go to the PIC16 programmer tool. So here select the microcontroller. PIC16F877A is the one we are using here. This one. Now go to the file, import hex file. This is the file we just created. Double click on it, recheck. Okay, this is the file DHT11 output. Okay, now click on write. Okay, the new file is being written. Let's get to the hardware and see what happens. So we are at the hardware. Let it write the new file. Okay, see that USB to TTL device is blinking blue light. It means the data is being sent. This is the TX pin blinking. Now we go to the USART terminal and see what is the data we are getting. So go back to the MikroC and let me zoom in for you. Now go to the tools. In the tools you have here is the USART terminal. Click on it. This terminal pops up. Select the port on which your device is connected. That is the COM8 in my case. 9600 is the baud rate we set in the programming. Rest are the default. Click on connect. Okay, you can see that we are getting the data here. Temperature 20 degrees centigrade, humidity 64%. So it will keep on sending the data as per our requirement. So it is simple as that. So if you still have guys any questions, you can ask in the comment section. I will share the link to the previous video from where I copied the code. In that video, I had explained the code in detail. So you can watch that code, that video in case you want to again revise the code. So guys, Thank you very much for your time. If you have any questions, you can ask me in the comment section, and we'll see you in the next video. Goodbye until then.